Okay, welcome back. I sent a few of those questions into our support team to see if anyone has any ideas. I'll let you know if I hear back before the course is done. Let's look at parallel processing. This is in some ways another one of those techniques where it sounds like, and I think people get very excited about, oh, this will immediately improve performance of my workspaces. And the answer again is it can. It's not guaranteed to improve your performance, but it's worth knowing about. So how parallel processing with FME works is it takes place in a specific subs, and you can control that through enclosing that section in a custom transformer. In order for parallel processing to work, you have to have some way of grouping your features, because you're going to send those into the custom transformer to be processed in groups, and each group will be processed in parallel. FME flow approach would be a little bit different. Normally, you would be running multiple workspaces in parallel as different jobs on multiple engines. So it's kind of, in some ways, I would say that's maybe a sort of more modern approach on the FME platform of how to do parallel processing. But you can also do it with custom transformers within a workspace. When you create a custom transformer, you'll see under transformer parameters, there is a parallel processing and group by setting, a parameter, I should say. You can see in the navigator window. Parallel processing by default is set to no parallelism, but you can control how much parallelism to introduce. So minimal, moderate, aggressive, and extreme are the options. When you change parallel processing to anything other than no parallelism, you'll have to set a value for group by, because as I mentioned, that's how this works. You need to give the transformer a attribute to group the transformers or the features on. And then there's a little bit of a, zoom in a bit here. There's a bit of a guide here for how many processes you'll be able to run based on your machine. So this is based on the number of cores you have on your machine and the parallelism parameter you select. So as your cores go up and as your parallelism selection goes up, you can run more processes. Oh, there's some typos here. These should be plural as well, shouldn't they? Make a note of that. So the most you can run up to would be 16 parallel processes. That's if you have an 8-core machine in extreme setting. This is physical cores. So cores on your CPU. And these are the hard caps. 2 cores max 4, 4 cores max 8, 8 cores max 16. And the total highest cap is 16. So this is the total number of processes that could run at one time. Yeah, it's irrelevant if you have more than 8 cores. We cannot go higher than 16 currently. 16 cores with moderate is 8 processes. So you can just, 16 cores with moderate would be the same as 8 cores with moderate. So it would be 8. I guess so. In theory, actually, this should say 8 cores or more, shouldn't it? I can change that. So this is the most that would be processed at one time. You can divide your data into more groups than processes, and it will simply, when one is finished, it'll start the next one. So you could run 32 groups into a custom transformer with parallelism, and that would still work. It's just a matter of how many would be running at one time. Yeah, this is for a single form license. But adding additional form licenses to your machine, for example, won't change the number of parallel processing you can do on a single machine. One thing to note is you cannot just pick an attribute to use for the group by. You have to use a published parameter. So group by will be one of the published parameters for the transformer. So that basically means it can't be fixed within the custom transformer. You do have to make it published. Now, all of that said, people are getting excited. Ooh, parallel processing, performance improvements. This is really effective in 2 specific scenarios. So the first is if you have a small number of groups and a large amount of processing. If you have many small groups, parallel processing very likely won't offer you any performance improvements. It's really better when you have a small number of groups. And by small, I'm referring to, I think when we've looked at it, it's been essentially 16 or less, maybe even smaller, 8 or 4. And you have a lot of processing you have to do. It seems like those situations tend to benefit more from parallel processing. I think the idea there being that once you split the processing into multiple processes, there's startup costs and shutdown costs associated with each process. And so if you're starting up and then doing a little bit of work and then shutting down, and you're just doing that a lot, it's not going to end up being any faster. And in fact, you can see you can actually make workspaces much slower by turning on parallel processing with custom transformers. So again, first scenario is small number of groups, each of which has a large amount of processing. And then the second scenario is many small tasks that the workspace is offloading elsewhere. So if you're passing features to a web service through a HTTP caller, you can have FME fire off a lot of requests at once. So it isn't doing a lot of work, but it's sending work elsewhere to be done. So if in that scenario, you can sometimes also benefit from parallel processing. But it is a sort of thing you kind of have to test and benchmark. And you should really only bother testing and benchmarking if you're in one of those 2 scenarios. Yeah, I would say first, try it with larger groups first, a small number of larger groups first, and see how the performance improvement is. If you immediately don't see a performance improvement from doing a small number of large groups, then I would say it probably isn't worth continuing. You could try to increase the number of groups after seeing performance improvements and see what the change is. But you should, yeah, it's a good idea to start with larger groups first, or a small number of larger groups. So in terms of designing this, big design question is, what will I group by, right? So you're going to have to figure out a good way to do that. And of course, that will be connected to, I would prefer probably to have a small number of large groups. So what's a small number of groups I can split my data into is kind of the design question. These will always work by splitting into groups, processing separately, and then combining back together. You don't get separate group output. It's just for processing, so you'll receive one stream of features at the end. The different groups can't be related, right? They're going to be processed entirely independently, so you can't have them be reliant on one another at all. And you can basically think of it like a group-based transformer. That's basically what you're doing here. So hopefully in your data, you do have some way of separating it out into groups. However, you can artificially separate it if you'd like by creating groups. So you could do that, for example, using a modulo counter or a random number generator. So here we have a modulo counter going in. It's got a counter name named mod counter. The count maximum is 8. So what that does is it counts, believe how that counts is 0, 1, 2, 3, 4, 5, 6, 7, and then it restarts at 0, I think is what happens as a counter. And so you can then use that as your group ID. And the parallel processing group by here is set to use that attribute. And then generally, if you're going to create artificial groups, you should target the maximum number of processes as your group size. So in this case, if we're running on a machine that has 8 max processes, that's why we've set the count maximum to 8. That's not quite as important if you already have pre-existing groups. but it is worth noting. And one thing which I thought we talked about in here, doesn't look like we do. We don't actually talk about sorting in here. Which actually strikes me as being kind of important, but now I'm not sure. We haven't mentioned it, and I don't know if there's a good reason. Let me make a note of this. Because you'll notice, I think we talk more about this tomorrow. Yeah, we talk more about this tomorrow. Maybe that's why we don't mention it here. But if you're doing group-based transformers, in general, you can get performance improvements if your data is sorted by group. However, it usually means your data already needs to be sorted by group to get those improvements, because if you have it unsorted and you try to sort it, that's going to add time, which often negates any performance improvements you would have. So it's more like if your data is already sorted when it arrives at FME by group, you can choose. It's available in group-based transformers. What's it called? Complete groups. So when all features received means it's going to wait for all of them, but you can also change that to when group changes advanced, which relies on it being sorted. Now, I don't know, actually, with parallel processing, I would assume you might have benefits there as well if the data was already sorted, but we haven't talked about it in here, so I'm not actually sure. I'd have to go check that as well. I'm not sure, Ryan, if you had any idea there. I think I would expect it would work like other group-based transformers where you could potentially get an improvement if it's already sorted, but I'll have to go confirm that.